Today we're going to be talking about the concepts of dark matter and dark energy from the perspective of the principle of incommensurability. Now, everyone has their own ideas of what dark matter and dark energy are. Some people might want to say that dark matter and dark energy don't exist, but I'm not going to go there. I have an idea based on the Mandelbrot Fractal. I have an idea of what dark matter and dark energy could be if they exist. So if we need dark matter and dark energy to develop a cosmology, if we observe them, if we need them, then I have an idea of what they might be. And so everything I know about dark matter and dark energy, I learned from the Mandelbrot set. So, of course, the two very important burning scientific questions are what is dark matter and what is dark energy? If dark matter is matter, what is it made of? What are the particles? Are they particles that can be discovered? Is this something we can actually physically measure and see? So what is dark matter is the scientific question. And what is dark energy? The same questions. What is dark energy? Where does it come from? Why does, what, if it's energy, what kind of energy is it? And that sort of thing. So the what questions are the scientific questions, and the why questions, are the philosophical questions. Okay, I made a little typo there. That should have said philosophical questions. So the philosophical questions are why dark matter and why dark energy. If dark matter and dark energy exist, then why? Why do we need dark matter? Why does it exist in the proportions that we measure, that we think we're measuring, that we see, that we observe? So those are all the why questions, okay? Regardless of what dark matter is and what dark energy is, I think really the underlying question is why does the universe need such things in order for the universe to exist? Okay, so there's one thing that we do know for sure about what we think is dark matter and what we think is dark energy, that when you combine the dark matter and the dark energy together, then what we see, the visible universe, is only 5% of the total. Okay, it's only 5% of the total. So the visible universe, only seems to only make up 5% of what we sense is there, what we think is there, based on certain laws of physics that man created. So are the laws wrong? Do we have it all wrong? Does dark matter not exist? Does dark energy not exist? Well, I'm not so sure. Okay, so what I see in the Mandelbrot set is the boundary here. This fuzzy boundary here is what I refer to as organized matter, or you might want to call it visible matter. So the visible matter, the only part of the Mandelbrot set that matters, is really this fuzzy boundary. Okay, when I zoom in on the Mandelbrot set, I don't want to zoom in over here in this open region here, because there's not going to be any interesting fractals in there. And I don't want to zoom in here, because there are no interesting fractals in there. The interesting fractals are on this very tiny boundary, which you can see, which is visible. Okay, you can visibly see this. So let me just run my software and we can have a quick look at this boundary here. Okay, so here we are zooming into the boundary of the Mandelbrot fractal. And as you can see, the more you zoom into this boundary, the more complex this boundary becomes. Okay, so this is visible matter. everything on this edge here that looks like structure is analogous to visible matter in my model. And so what I'm going to say is that let me go back to this slide. So basically what I'm saying is, in terms of the Mandelbrot model, the black region corresponds to dark matter. The outer gradient region corresponds to dark energy. And the, approximately 5% of this very tiny, very thin boundary is what I am calling visible matter. Okay, so, and the proportions are very similar. Okay, dark matter in the universe, we're saying it's somewhere between, 25%, and this makes up about 25% of this image here. I'm only counting inside the 2.0 boundary radius because that's where the Mandelbrot ends. And so everything, if you measure everything inside the circle, you'll find that the dark matter makes up about, 20-25%, and the dark energy makes up, like 75-80%. And the missing, the rest is this little boundary condition, which of course, when you zoom in, when you zoom in, you find more and more structure. So this, dark matter, dark energy proportions, I think, can be taken at all scales. And so, but it's the main Mandelbrot that counts here. So this is the whole universe. So when you're looking at the whole universe, right, 20-25% is dark matter, 60-70% is dark energy, and 1, 2, 3, 4, 5%, depending on how closely you measure this. We can just say this makes up this boundary here. When I measure the volume, the area, the surface area of this region here, it's going to be, around this value. And so dark matter, the Mandelbrot set taught me a little bit about dark matter and dark energy in terms of, if we live in a fractal universe, if we live in a Mandelbrot universe, and the black region is dark matter, counter space, inner world. You can now apply all those terms to this region, and the outer region, or black hole as well. You could apply to this region anything that's contained, counterspatial, etc. And so this is the incommensurability. So dark matter and dark energy are incommensurate principles, and visible matter is the interface between dark matter and dark energy, counter space and space, inner world and outer world, black hole, photon sphere, nucleus, electron shells. Okay, so this is the fractal paradigm. I'm using the fractal paradigm and the principle of incommensurability to bring many, many, many different concepts together into a few simple ideas, into a few simple concepts. And so this would be nucleus of atom, a black hole, dark matter. This is the dark phenomenon at many, many scales, and also in many situations, including the Mandelbrot set as iterated through the function z equals z squared plus c. So this is a principle. This is what I'm trying to do here, is develop a principle that ties various concepts together. Concepts from nature, concepts from electronics, electricity, light, sound. So bringing all these concepts together into one framework, one simple framework that has a very nice visualization that's easy to understand and easy to remember. And so that is the point I want to make today. So dark matter and dark energy, dark matter and dark energy are incommensurate principles, and visible matter exists at the interface between dark matter, dark energy, counter space, space, inner world, outer world. Okay, so that is the point I want to make in in all these videos actually. And so this is just one more set of concepts that can be easily applied to the Mandelbrot set and to the complex plane in general, and maybe begin to answer some of those philosophical why dark matter, why dark energy. Because we live in, if we live in a fractal universe, and it is very Mandelbrot-like, in my opinion, then this may explain why we need such a thing as dark matter that's almost 25% of the universe, and dark energy that's almost 70% of the universe, maybe more. This may explain why these things must exist. Okay, so that's all I'm going to say about this subject, and I guess I'll be back.